Talking about separation of mixtures. So, mixtures are physical mixtures. They're just particles that are sitting next to each other. So they can be separated by physical means, which means just pulled apart. So the first method of separation that we're going to talk about is filtration. Filtration is separating by using a porous barrier, and porous means has holes in it. Now, these holes can be very large, like a beach sieve, like you used when you were little to separate the sand and the shells. Or they can be very small, as in a coffee filter, or even smaller than a coffee filter. All right? And what you're separating it by is the difference in the sizes of the particles. So you're very familiar with this method. We use this even in AP chemistry, where we take a solution of like copper sulfate that has silver molecules or copper molecules. It might be silver chloride, and it has silver molecules in it, and we pull it through using even a funnel with a vacuum pump on it to pull the solution through, and then we can filter out the silver or the copper molecules that's in the solution. So they can be very, very small. They can filter out even virus particles, or it can filter out bacteria. So the holes can be very small. Next is distillation, which is separating using the difference in boiling temperatures. So for example, water has a boiling temperature of 100 degrees Celsius. Sorry, that's very messy. Water, 100 degrees Celsius, that is a disaster. Water has a boiling point, let's try that again, of 100 degrees Celsius, while alcohol, for example, has a boiling temperature of around, so approximately 79 degrees Celsius. So if we were to set our temperature setting at about 72 degrees Celsius or 73 degrees Celsius, the alcohol would begin to boil off first, leaving the water behind. Some of the water might boil off because you can leave a glass of water sitting out in a room and it still evaporates off, even though room temperature is about 25 degrees Celsius. So some of that water would boil off, but far more alcohol would boil off first. So you can separate them by boiling temperature. You could even put it around 50 degrees Celsius and keep it very low. And then the alcohol would boil off first. Lastly, chromatography, which is separating using the density of the substances and the ability to move across another material. So let me show you a picture of that. Here on the back of your sheet is an example of chromatography. So what they do is you can put a substance into a solvent, which will dissolve it into the solvent. But what you're going to do is you're going to put a spot of the substance onto a piece of chromatography paper, which is a little like a paper towel. It absorbs the solvent. And then you dip the chromatography paper into a solvent, and the solvent is absorbed up the paper as it would be if it was a paper towel. Like you dip the corner of a paper towel in, and the water starts to absorb up the paper towel. You've seen that, right? So it starts to get absorbed up. As it passes over the spot of the substance, it dissolves it. And it starts to carry it up the chromatography paper with it. And it separates it out into its components. And as the components get farther and farther up the chromatography paper, they drop out according to their density. The highest density drops out first. So you can do this with colors. Like I can do a demo for you. When we come back during the review, I will have a demo set up with markers, and I can show you how markers separate by color according to the density of the ink. And you've seen that because you've seen water get splashed onto magic markers and they separate into the different colors, and we call it running. We say like, oh, my drawing, it ran, right? Water got on it and the colors ran. That's what that means. They separated according to their density, right? And if it was upright, they would climb up the paper and they would drop out according to their density. And that's what chromatography